right, time for another DraftPhysics.com, debatephysics.com also, but yeah, can't find any good debating, just can't solicit any kind of rational response to the arguments made, and it's disappointing, but it's the way of the world. So this is Shankar, I can't remember his first name, Million, something like that. Anyway, of Yale, and very nice, personable kind of fellow. He kind of got like a professor had to leave, and he just filled in sort of thing. And it's like he's a theoretical physicist, and he really want to be doing this and blah 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 and all kinds of crap, but whatever. And he did a fairly good job. This is where he's talking about the two slit in the conventional 101 type physics, and then he does it again when he starts talking about quantum mechanics. So I'm actually going to play both the videos because he makes these same mistakes. It's just such a cheat of the truth, and this isn't it's just not good science, and it's in this context like Feynman of people telling us how important this is and how important that is, and evidence of this and this, and then they break their own rules, and it's like, come on. Somebody should call bullshit, and it shouldn't just be me. But anyway, it turns out that's just me. So I think this part he's still talking a little bit about the importance of evidence, and the evidence is if it's against you, it's against you. If it's for you, it's for you, kind of thing. Obviously, this is important, but it's all interpretations of evidence and how well you understand experiments. And so, if you don't know that springs expand at different rates, and it's going to matter how fast it's expanding when it's pushing something, so it's not going to give quite as much energy to a light thing as it would give to a heavier thing. There's lots of catches, and if no one's catching any of the catches, you're not going to do good science. And so here he's going to talk about this double slit experiment in such a simplistic and unfair manner that it's just junk science. It just makes it look like a religion.
But if you let V over C go to 0, then you'll find you get back Newtonian mechanics. Similarly, quantum mechanics works for very, very tiny objects, the atomic scale, but when you apply it to big things, you will find that the world begins to look Newtonian. Similarly,
so this is just basically math nonsense, and the fact is that, yes, I think if you always rely on Newtonian momentum, you'll always get a right answer. So until somebody shows me where momentum will steal you wrong, I think it's reliable all the way, biggest to the smallest.
The end of geometric optics came from a series of experiments, and I will tell you why we didn't realize there was something wrong with it for a while. So here's an experiment you could do. Here's a screen, and there's some light coming from here, and there's a hole, and behind the screen is another screen.
All right, so this is just this is one of Newton's experiments, just taking an aperture, making it smaller and smaller and smaller and smaller and smaller. So there's just a hole and you're making it smaller. And what happens when you do that? Well, you get a nice cone of light, okay, that hits the screen. And as you start making it smaller, it gets, smaller. And then there's a point where all of a sudden it's big, because you're increasing the number of photons that are going to interact with the surface is the simple answer. What's the difference between this hole and this hole? Well, in this hole, 90% of the photons are going to be near a surface, and in this one, only 1% is going to be near a surface. Simple enough explanation. Now, they'll never say anything like that, ever, because they want to say it's Heisenberg. They want to say it's some other thing that's causing the effect, when the obvious thing is, no, it's the surface causing the effect.
So I'm not good at drawing. So you should imagine this is coming out of the blackboard, and a ray of light is coming in. It'll form a shadow I happen to have in mind a circular hole here, you'll form a disk shaped exactly like that. And another thing, but you will find that as you shrink this, make it smaller and smaller, suddenly that won't be true anymore. You will find that the light spreads out like that to bigger and bigger areas. So it's no longer forming the.
So if you really do it carefully, you'll find that what it really does create is a bunch of rings. So again, he's really cheating the argument. It's basically doing a single slit experiment in every direction. So instead of having linear slits, you're basically just saying, I'm going to have a slit experiment in all directions. So you're going to get a fringe pattern that's just basically representing a circle, because the equidistance is because it's a perfect circle.
The geometric image of this aperture, it's fanning out. That's not going to come from the geometrical optics. So that's one experiment where something goes wrong. But it's a more dramatic experiment. It's really.
So that one's pretty dramatic. So again, it's really just saying that's the single slit experiment. And you can just measure the rings just like you measure the fringes.
It puts the nail on all kinds of ray theories. That's the experiment involving interference.
So he says he's putting the nail in the coffin, the same rhetoric that Professor Lewin uses, that somehow this experiment demonstrates that it's waves, when if you pay any attention to the math that works, you notice it has nothing to do with wave centers. So it can't be waves because the function isn't where the wave centers would be in their diagram. So it doesn't fit at all. The fact that they can't acknowledge that, no, that's just not a good enough explanation. You can't pretend your math doesn't have to fit your diagram. Yeah, it does.
So you take a partition with two holes in it, and you send light from here, and you put a screen behind. Are you guys with me? This is a cross section of a plate coming out of the blackboard. It's got only two holes in it. Or here's a better way to think about it. This is the top view of an experiment. I'm looking down at my lab from the top. That's a wall with two holes in it, and that's the back wall, and the light is coming from here. If I close this hole, what you will find typically, let me make them slightly bigger to make my.
So what you will find typically is they've never even bothered to do this simple experiment. So that's the big joke here. So I'll draw this part. It's just so fundamental, and you're just saying, he just says what you will find typically. You never did it. It's a simple truth. He has, he has no deep understanding of this fundamental experiment that he's going to use as an argument, saying this is why you must believe us when we say this is how it works. And they have no clue how it works. I got to find my pen. All right, so the first thing I understand, like when the experiment was done before laser beams, what they would do is have a slit, a single slit, to attempt to make the light coherent or straight. Okay, so there's not a whole bunch of light going in directions like this or like this through the opening. All right, they want to have the light hit the surface and continue to go straight. So the idea is when it goes through the slits, especially if you're using a laser beam, the light goes straight. Okay, it doesn't go at these angles through the opening. That doesn't happen. All right, so there is no light spreading without the slits. The slits are what creating all the fringes. Okay, so the simple argument is you've eliminated that capacity. So you have to understand that this is less than a millimeter, and that any photons going this way and this way are going to be inside of 1 millimeter when they hit the screen, no matter how far away the screen is. This is a tiny little spot, less than a millimeter, and the light that goes straight is going to be confined to a space of 1 millimeter. All right, now the lasers do spread a little. So at 10 meters, it might spread to 2 millimeters. It might make a little bit of a difference, but it's not going to make much. And clearly one side isn't going to go over here, and this one isn't going to go over here. So on the screen, you're never going to see, if I open this slit, I'm not going to get a hump over here. And then when I open this slit, I get a hump over here. That's never going to happen. What's going to happen is, if you do the experiment, is that if you open one slit in that location, that close to the other slit, you'll get this simple, effect of you're going to have a pattern when this one's closed and this one's open. You're going to get a little bit of a bow in the light. And when this other one is closed and the other one's open, it's going to be only less than a millimeter's difference. So the two are going to be right on top of each other. You're never going to be able to see the difference when you're creating a pattern on the wall that might be 6 or 7 inches across, that's being created by the fraction of the laser with distance. You're not going to see a millimeter of difference between those two patterns, and that's 7 inches. You're not going to see 1 millimeter. So this is what you're going to get. So they can't even get this part right. I mean, it's these are the basic elements of the experiment, and they're contriving, mysteries that don't really exist, by implying a circumstance that doesn't exist. I need this back.
A point, you will find some light. I didn't draw it properly. Most of the brightest areas will be in front of this hole.
so he actually do it more correctly, and now he's going to he's going to make it less correct, because he has to try to make these two patterns end up in two different locations on the screen, and they won't be in two different locations on the screen. They'll be right on top of each other.
So let's see. It'll tend to be big here and kind of fall off. Now if you block the other one and you shine light here, you get something like that.
All right, and that is only if you have a slit that's less than a wavelength of light. To get that blob, you have to have an infinitesimally small slit or a gigantically wide open one, so wide that you're not going to see any fringe pattern, because so much light just goes right through and bleeds the whole thing out. And your fringes will be so tiny that you wouldn't be able to see them. So it's only under special circumstance. So under the normal circumstance, with those slits open, with one slit open, you're going to get a bar pattern, a fringe pattern. And then with the other slit open, you're going to get a fringe pattern that's almost exactly the same thing right on top of it. That's what you're going to get. That's what actually happens if you actually do the experiment, which I've actually done. Okay, so continuing.
It's like two windows in the room. You got one window, you get some sunlight, you get another one, you get another sunlight.
All right, so it's nothing like windows. Well, obviously, I know windows are gigantic and the surfaces are a million miles away from each other as far as photons are concerned. And so your fringes are completely wiped out by the abundance of photons going straight through the window.
Now the question is, if you open both of them, our expectation is that there is some energy coming here, some energy coming here.
All right, and so this is where they turn a double slit into a single slit experiment. So he's assuming now that we have a very infinitesimally small opening to create just this blob. And then we and so both openings are really small, so you don't get any fringe pattern essentially, because there's no vectors from those two surfaces. The gap is so small that you can't make a wavelength of difference in the lines anywhere, so you can't create fringes. All right, you can't put it out of phase and in phase and out of phase and in phase.
And if you open both, you should get the sum of the two energy.
So that wouldn't be the sum anyway of two lumps this far apart. So the sum would not be this. All right. But anyway, let's continue.
Which I'm assuming this is the sum of these two graphs plotted here.
You'd obviously get a peak here, okay, where there's more light. And obviously in the experiment you get a peak there where there's more light. So that's not a big surprise.
By the way, do you know how I'm plotting this? I hope you understand that this graph really means that distance is proportional to how bright this point is. See, normally it used to drawing graphs like this as a function of distance, but I've turned it around so that that is the graph of the brightness at different points on the screen. That's what you expect. You open two windows, you get the light equal to the sum of the two. For example, if you're feeling warm, it'll be warm.
All right, so again, I'll just reiterate. Obviously, these aren't windows. They're tiny little openings, and they're a distance away from each other that is infinitesimally small. So obviously, whatever pattern they create on the wall is going to be within that tiny amount of distance. The light travels in a straight line, essentially, and the whole point of doing the experiment with a laser or with a great deal of distance and an opening with a great deal of distance is to force the light to be moving in a straight line.
Somewhere in this region, because you're getting light from two sources.
So it doesn't happen. I'm just saying that's the point here. So he's saying two sources are creating light in that location, and it's not the truth, because at all the locations there's going to be two sources producing light, because it's only going to be this tiny little distance between the two patterns. So the patterns are, let's say he opened those slits enough to have a fringe pattern. Those two fringe patterns might be a foot across on the screen, and you're talking about less than a half a millimeter of difference in where they're going to be located, opening one slit versus opening the other slit. Those are the facts. The light travels in a straight line. It goes to the target trying to duplicate where it came from.
But this experiment also gives you different results under certain conditions. I'll tell you what the conditions are.
So this is where they, again, why would you not describe the experiment in its what it fully can do? So let me just draw that, all right, just to point out how far his drawing is going to be from the truth. It's like in no way is it connected to what actually happens in the real world. So the double slit pattern, if you have the slits open, and I've drawn this so many times, will look like something like this. All right. Whoops, that's supposed to be 3. And so it has these obvious little breaks in it, okay? Now, if you really examine it, these breaks mean really there's just the shadow, okay, of a dot in between there, and a shadow of a dot there, and a shadow. So you have a little bit of a dot, not very bright. And I don't mean smart. So obviously this is the classic double slit, and essentially you have this envelope pattern, it's called. So you have two patterns. You have the little bits with a consistent distance between them, and the big bits. And then you obviously have this idea that these nodes are, this node in the middle is almost twice as much as all the rest of the nodes. So it's like a double maxima, they call it. So right there you're saying, okay, that's a very complex pattern, and depending on how far away I put the slits and how big the slits are, I can change this number to any odd number. So 1, 3, 5, 7, 9, 11, 13, and really once you get to something like in the 20s, you're going to it's starting to become impossible to see because the little bars are getting awful close together. But you can have a great range in how many, the one is really not possible, I don't think. Whatever. So, there's a great range in how this pattern will look, depending on how open the slits are, and how big the middle impediment is. You can change this quite a bit. And the simple truth is the mathematics is basically saying it's really easy to understand what you did when you brought these two single slits together, right? So you're taking two single slit experiments and crashing them into each other, moving them into each other. And what the difference is you really created is this distance here. And that's what creates the little dots. So the little dots, this distance will tell you exactly how many little dots there'll be. This distance divided by the wavelength. So if I divide the wavelength into that distance, it'll tell me exactly how many dots there'll be going this way in one arc. And all I do is double that to get the total for the whole pattern. And this smaller distances, the average of say these two, the small distances, that'll tell you the size of these bars. So That's what the math says. So it's clearly the surfaces that are causing the phenomenon. So any idea that two waves are coming out of the surface, the slits, two waves are coming out of the slit, is totally blown up by this idea that clearly it's the surfaces. The math is describing the surfaces. The math isn't describing anything to do with the photons going through the opening. It's describing what happens at the surfaces. The surfaces are creating the entire phenomenon. Now the fact is, when you take a double slit and you make the slits infinitesimally small, you can sort of understand that there can't be a wavelength from the two surfaces. So you've nullified two of the surfaces essentially. So you took a 4-surface experiment and you nullified it by making two of the surfaces so close together, okay, that there's not a wavelength of difference between two of the sources. So now I only really have the 2-source experiment again. So I can turn the double slit pattern into a single slit pattern. So what did I get rid of? I got rid of two of the distances, and I'm only stuck with one distance now. And so I'm going to get one pattern, okay, that will look probably something like this. All right, you'll have a double maxima, and the same rules apply, except it won't have the little discrete bits in the center. So that's all I've done, is I've taken what would have been a double slit pattern, and by making the two surfaces so close to each other, I got rid of two of the sources. So now I only have a 2-source experiment. And that's the truth. That's the math that works. That's the math that describes the experiment. And that's the real pattern. And what he's talking doesn't have anything to do with those facts. And, that should bother somebody besides just me. Not a little problem with the pause button, but let's see what happens.
That's called interference. The main point to notice is there are some places, like right here, where you get less light with one more slit open.
All right, so that's a statement that I would argue has never been proven. So Veritasium did a version of the experiment. He bought the kit, all right, $10,000 kit, and he couldn't get it to work as a time lapse kind of thing. Like you should do the experiment. The original doing of the experiment was you create a very small amount of light, one photon at a time. You allow the thing to take place, and you can do some of this demonstrating. But it's Veritasium had to reduce the experiment instead of 5 days to 5 minutes to get it to work at all, to get any pattern at all. So the idea of measuring the amount of photons covering slits, okay, the real problem is the exposure of your camera. So as I pointed out before, I guess I could draw it, which I guess I got to try to do. So the idea, look, the Veritasium single photon experiment, the joke is that, he got a pattern eventually, okay, but it was a pattern built on 50% noise, okay. So you can understand 50% of the photons weren't obeying any of these rules. And that's sort of the joke of it is that there's an amount of light, and then you're making a change in the amount of light based on 2 sources versus 4 sources. And the fact is the pattern's still there with the 2 sources. It's just very weak. And there's a squared function in the probability. The more sources you have, the greater the multiplication of your matches, so to speak. So the fact is that if you have one slit open, there's a certain amount of light at a location. And then if you have 2 slits open, you're going to get 4 times that amount of light if all 4 sources point to it. So the idea is that there's no point that actually you get to see complete bright and complete dark. The complete darks aren't completely dark. There's no place that both sources don't make a photon. There's just a difference between the one opening creating a photon and the other opening creating a photon. Those are half or a quarter of what it is when they both point to the same place. So if they both hit the same place, all right, then you're getting 4 intensity, and it's only 2 intensity where only 2 of them hit, you could argue. And so no place actually goes from, no place that was dark, was light, turns to dark. It just stays as bright as it was, and the other spots get brighter. So if you have a camera that's constantly adjusting to how many photons, obviously when you have both open, you have twice as much light, so the aperture in the camera is going to close. So it's just going to defeat the purpose. So the only way you can do the experiment, honestly, is to make sure the aperture is fixed. And if it's fixed, you'll notice the fact. And I sort of pointed it out earlier when I pointed out that if you really look at the complex pattern where it's made up of the dots, all right, and you look at these dark spots, you'll see the little hint of a spot in there. You know, I can't really draw a half a spot, but yeah, you see a little spot, you know, indicating, yes, there is actually one there. You're just not seeing it because it's not bright enough, because it's not getting light from both sources. And that's the key to the experiment, is 4 sources producing in-phase photon versus just 2 sources producing an in-phase photon, and the 4 sources creates more light. So it's just I don't know what I call it. It's misrepresenting the truth for him to say it happens, because he has no experiment showing it happening. So that's just the truth. There's no credible experiment showing this place where it's a certain intensity and it actually goes down. There's no experiment that shows that. So, this and this.
Okay. And
I mean, it's a huge argument, right? I mean, this is sort of like the pendulum, one mass hitting a 3 mass and creating more momentum. If you can actually prove this stuff happens, it's a hell of a great argument. But they don't actually prove it happens. They don't ever prove this to happen.
more light with only 1 open, less light with 2 open. In fact, you can arrange it so this is really 0.
So it's never 0. Like I said, if you really look at these patterns, there's no such thing as 0 anywhere. So if you do them in complete darkness, you'll see there's photons going all kinds of places. So you get all kinds of random noise photons. So it's just, and again, the Veritasium experiment kind of proved that when he's doing the single photon. Half the photons were noise photons. Half of them.
I mean, it can come all the way down here.
So it doesn't happen.
In other words, that's the point on the screen, which used to be bright with 1 slit open. I open the second one, that point becomes dark.
So it doesn't happen. Just verify, state it, okay? Show me. So if somebody has a good piece of evidence that that actually happens, good luck. The only one you can find, I could find, was some done by Christian scientists, okay, who used the same toy that Veritasium purchased, and they have a filter on, and the filter is creating the effect. It didn't happen in the actual photons. It just had to do with what photons they filtered out of the experiment. That is, all the photons that I can't remember the rule, but the ones that arrived at this, next, like very close in time to each other, like if one hit and then another one hit the millisecond later, they canceled those photons. So, that's sort of like absolute bullshit, right? You're canceling some of the photons? Why? Oh, that's right, because they would prove that it's brighter than it looks. It's brighter than you are claiming it to be. So the only way you can claim it to be less is you have to eliminate some of the photons out of the data.
That means if you're warned there and you tell somebody, hey, this is good, open another window, suddenly you get nothing. That happens. So how...
All right, so again, if that were true, it'd be a hell of an argument. But it simply isn't true. And the fact that you can't find any experiments demonstrating it to be true proves that this is just part of the myth. This is mythology. This is not physics. This isn't science.
When did people realize this is what happens? And why did people fall for the other graph that looks like this before?
All right, and fall for is the key thing, right? Because nobody did the experiment. So falling for it only happens because somebody told you so. So it's like falling for religion. Okay, they don't show you any evidence. You're just supposed to fall for the story. And that's all science has done, is fall for this fake story they tell about this double slit. And then, others add the detectors and all kinds of other bullshit that never happened. So it's all mythology. There's nothing real here. It's fabiology. They're just writing fables about science. This isn't the true story of science.
The answer is this. In order to see this phenomenon, in which instead of being a shadow like this, you get a huge spread, or instead of being simply the sum of these two featureless graphs, it starts oscillating, a certain condition has to be satisfied.
So whatever this oscillating part, right? So if you look at the pattern, it's not oscillating. So it's all just, again, this fake notion that it has something to do with water, which oscillates. This doesn't have anything to do with water and oscillations.
The condition is the following. This light, if it has a wavelength lambda, the lambda, if it is much, much smaller than any distance in the problem, then you get geometrical optics.
Right, and it doesn't matter. What you can well establish from the math is that the distance, the number of wavelengths that fit, is the base of a simple Pythagorean triangle, and you're just going to figure out that whenever the hypotenuse is a full wavelength of difference, that's definitely an on. So however many wavelengths fit through whatever you're measuring is going to decide exactly how many of these bumps there is going to be. And they never say that. They imply that this is a pattern that could go infinitely on a flat surface or something. It can't do any of that. And in fact, the nodes actually get bigger as you go down these angles. So they're smallest here and they're largest here because of the whole way the circular geometry works. That you're going further this way than you're going up, as you go the curve, blah, blah, blah.
So in this example, if the slit is 1,000 times the wavelength of light, then the shadow...
Right, so if it's 1,000 times, that means you're going to get 1,000 little bars if you go the whole 90 degrees. So that whole 90 degrees going this way would be 1,000 bars. So you can just calculate based on how big your pattern is and how far it is from the surface. You could calculate, 1,000 bars is going to mean they'll be a millimeter apart or something. That's the fact of it. So if make it 2,000, that's how simple it is.
Shadow, in fact, will be geometrical. But as you make the slit smaller and smaller till it becomes comparable to the wavelength, then you'll find it...
So if you make it comparable to the wavelength, there can't be any triangle. There's no... If I have the base of the triangle is very small, then I can't make a line anywhere into space where I'm going to have a wavelength of difference in those two lines because they're essentially coming from the same point in a sense. There's not enough difference between them here to create any difference here. And so I have to have more than a wavelength if I'm going to create fringes.
Begins to fan out. Similarly here, if this distance between the two slits, d, is much, much bigger than the wavelength, and each slit is much, much bigger than the wavelength, then you will...
Right, so bigger than the wavelength. Then I'm going to get the complex pattern I drew. But he's not going to say that. He's not going to show that. So we have a big impediment, big distances, and we have openings that are big. That gives you the complex pattern that has two patterns. He's not going to say that.
Find that you don't see any of this.
It's absolute nonsense. You see all kinds of it. You see even more of it. You see two different patterns doing that. So you see that inside of this. So you see two patterns piled on top of each other. So is how far from the truth does he have to be before somebody says, wait, foul, what is this? This is what you pay for? I mean, you pay thousands of dollars to be educated with this nonsense? These statements that just clearly aren't true. It's just plainly wrong, and it's a fundamental experiment. It's fundamental to quantum mechanics. This is what started it all. And they can't describe it accurately ever.
interference.
Because frankly, the truth doesn't prove waves, it proves particles. It proves the surfaces are controlling the experiment. The photons that become fringes have to be photons that went near a surface, because all of the vectors come from the surfaces. That's what the math proves. The math that gets the right answer has to use the surface as the location of the point source.
Effects. Because what happens is, interference effects are always there, but they oscillate like mad on that screen. Suppose it oscillates like this.
Right, so that would require you to have 50,000 or some other really big number, right? Because, I mean, 1,000 spread over 10 feet, you could understand that, okay, I could draw 1,000 lines on 10 feet of surface, and I'll see the difference between each line. But I can't do that for, you know, something with 1,000,000 lines.
And this could be 10,000 oscillations per centimeter.
Right, so the further away the surfaces are. So if I make the surfaces this far, we're talking about 1,000,000,000,000 lines. Right, so I'm not going to see any, if I see any fringe, it's just going to look like a blob, because I'm not going to see the individual lines, because the individual lines are so tiny, so thin. Right, but as I get smaller and smaller and smaller, I'm going to start making those nodes bigger and bigger and bigger. And the smaller and smaller I make the distance, the bigger and bigger the nodes get.
And your eye is able to look at it only 1 millimeter at a time, then you're averaging over a region, and you only find the average of this graph. That looks like what you got.
Right, so this doesn't happen though, because what you know is that the laser's just going straight through the opening, and there's only a tiny number of photons that are going by the surfaces. So 95% of light's just going straight through, and it's not getting fringed at all. There's no lines in the middle maxima. There's no lines in there, because none of that is doing this two source thing. It's just sending photons through. They were completely undisturbed. And they're not going to be diffracted at all. So they're not going to create anything. They're not going to create any fringe pattern. And they're certainly not creating any nodes. They're not doing the on-off thing.
Without interference. So in order to see interference, you need to make your apparatus probe the physics at a distance scale comparable to the wavelength.
So let's understand that just, no, it's not comparable to the wavelength. I don't want it to be just one wavelength. I want the slit to be open, and I want to have nodes created. So obviously, and so that's this. Like I said, they're pretending the single slit just creates a blob pattern, when obviously it can create, you know, dozens of nodes. So it's all bullshit.
So that's the answer. We will see all the details, but it'll turn out that if you look at light using any equipment, maybe a hole in the wall, 2 holes in the wall, whatever, whose dimensions are much bigger than the wavelength.
So he's saying that anything bigger than the wavelength somehow won't make a pattern, when of course it makes tons of pattern.
You will not see the wave theory of light. You'll be
So he's saying you won't see fringes. Of course you will.
able to get away with the geometric theory. But once you probe light at a length comparable to wavelength,
So if you do it comparable to the wavelength, you turn you turn a 4-source experiment into a 2-source experiment. That's all you do. So you make the slits infinitesimally small, wavelength of light small. All you do is say, okay, I got rid of 2 of the surfaces, and now I just have these 2. And these are the only 2 sources of photon.
all these funny things will happen. That's why people didn't realize all these things about light. For example, the wavelength of light, typical light is 5,000 angstroms, or 500 nanometers. That is 500 times 10 to the minus 9, or 5 times 10 to the minus 7 meters. That means, if you forget the 5, there are 10 million oscillations of the wave within 1 meter. So,
Right. So a meter is 10 million. Okay, so 10 million. And then if I go half that, then I'm down to 5 million. And then I go half that, I'm down to 250,000. And, I can just keep reducing. Well, 2,500,000.
If you have an instrument that can pick up that kind of fine features, then you will see the wave nature, but normally you won't.
So instead of just going from one wavelength, 500 nanometers, and just say, well, let's do something that's, a half a millimeter, which would be like 1,000. Well, that's reasonable. That we can do. That we can see.
So it's only when people probe light with very, very tiny holes placed very close to each other, they saw it. The second...
So again, it's so dishonest, because that's the whole point. You can vary it all kinds of ways and change the pattern dramatically. There's lots of variation in the pattern, the wider you make the slit, and the more it shows the actual truth. It shows what's causing the effect.
Important thing to remember is the following. Even if you made the holes very small, and if you shine white light on this, you will not see any of these patterns.
All right, so again, that's kind of wrong too. We know you'll see lots of the same patterns just to be on top of each other. So the red pattern will be superimposed on the blue pattern and the green pattern, so they'll all blend into each other, but you'll still be able to see the fact that they're creating nodes.
Why is that? Can you have a guess? I'm going to tell you everything, but can you guess why? Yes? You have a guess?
Because they're different wavelengths.
That's right. White light is made of many colors and many wavelengths. So each wavelength will form its own pattern, but the maximum and minimum of one guy won't coincide with that of the other. So where this one wants a maximum, that will want a minimum, it'll get washed out. So
It's not really about a maxima, the center, and minima. It's about where you have your ons, your in-phase ons, and your out-of-phase offs. So the in-phase ons and offs will be in different locations. But you can clearly see that the blue light's going to have bars, and the red light's going to have bars. And the fact that the bars don't line up is going to be distracting, but it's not going to take away from the fact that you can see that all the colors of the light are creating a bar pattern. That'll be quite obvious.
in order to see this effect, you need monochromatic light sent by...
So again, the only thing the monochromatic creates is a clarity in the terms of there's no distraction because you have the bar pattern misaligned. So it just means you can see the nodes clearly because there's no distraction of having other colors bleed over it.
by a source which is sending it at a definite frequency and wavelength. And these are all things you have to get right before you will see these effects.
Okay, so he's talking about getting things right, and he just explained critically two things that are just wrong. First, that you open a second slit and some place gets dark. That doesn't happen. And that you can't make this pattern by opening the slit just 500 wavelengths or 200 wavelengths.
Okay. So now let's ask ourselves, what is the nature of waves, or what is the nature of light that produces these funny effects? Light, as you know, obeys a wave equation.
All right, so this part we probably can live without. Yes, I'll let him draw this part, but yeah, we'll probably skip over this. And maybe I'll just jump to the other video.
Let me call psi as whatever it is that's doing the oscillation.
Right, so this is the magical function in the equation. And psi basically means all knowledge of how the system works. So they'll predict what will happen on a roulette wheel as long as you give them all the information about how it spins and how fast it's going and everything you need to know. Then you can do some predicting. But without complete knowledge, you're not going to be able to solve anything. So it's just mush math. I don't think there's anything else in this video that's very important, but I'll take a quick look and we'll just play the other one where he does exactly the same thing, and I'll just point out that, look, he's making the same mistakes twice. It's just really bad. Alright, so here's the second video where this is a completely different lecture further on in the series where now he's going to talk about quantum mechanics.
Fashion, the purely historical fashion is pedagogically not the best way, because you go through all the wrong tracks and you get confused and a lot of battles going on, and when the dust settles down, a certain picture emerges. And that's the picture I want to give you. In a way, I will appeal to experiments that were perhaps not done in the sequence in which I described them. But we know that if you did them, this is what the answer would be, and everyone agrees.
So everybody agrees, even though it's completely not connected to the truth in any way whatsoever. So that's religion.
And they are the simplest experiments.
Right, and they're so simple. So again, we're just back to arguments like, Leibniz saying 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. The lever says that's not this; those aren't the same quantities. They don't weigh the same. They don't create the same pressure. It doesn't work. They don't care.
All right. So today we're going to shoot down Newtonian mechanics and Maxwell's theory.
So, who knows exactly how he's doing that? But again, this, and it's just crap, frankly.
We're like the press. We build somebody up only to destroy them.
You're not going to destroy Newton because he was too careful in what he said. So frankly, he's pretty hard to destroy.
Up Newton, shot down. Built up Maxwell, going to get shot down. So again, I try to drill into all of you the notion that people get shot down because somebody else does a new experiment that probes an entirely new regime which had not been seen before. So it's not that people...
All right, so let's understand. This is the kind of a joke, too, because Newton did all of these experiments. Okay, he did the two-surface experiment. He did the single impediment experiment, which, again, is the two-surface experiment. Now, I don't think he did a double-slit experiment, but he already knew what fringes were. Obviously, it's called Newton's rings, right? The aperture rings. It's essentially the same thing. Tiny aperture creates lots of rings. Exactly the same phenomenon. So Newton was well aware of it. Unfortunately, he didn't provide, this is one of the things, he didn't provide a gigantic amount of information regarding why.
Were dumb. It's that given the information they had, they built the best theory that they could. And if you give me more additional information, more refined measurements, something to the 10th decimal place, I may have to change what I do.
All right, so all of this 10th decimal place when it's all circular, when you've invented the machine to do exactly what your math says, and then you just verify each other. They just confirm each other. And that's the only experiments they have. They haven't done any real experiments demonstrating any of this to be true.
That's how it's going to be. So that's always going to be, for example, in the big collider,
credible experiments.
People are expecting to see new stuff. Hopefully stuff that hasn't been explained by any existing theory.
Whatever. You can't even make any. There's no point in even talking about that because you're never going to see any of the raw data that draws them to these conclusions. You're not going to see that experiment.
And we all want that because we want some excitement. We want to find out new things. The best way not to worry about your old theories is to not do any experiments. Then you can go home. But that's not.
Yeah, let's all go home. I mean, let's draw some real conclusions. Okay, evolution's a fact. I could make 1,000 statements about how things took place, and they're really reliable. Consciousness is a brain function. These are statements that could be made. You just can't evade them. They're reasonably secure and beyond reasonable contention. And we got a ton of that. So let's get that done already, instead of playing this wooey game that you're expecting to find the God particle. Bullshit. You're not going to find any answers because you're looking in all the wrong places.
How it goes. You probe more and more stuff.
Doing the wrong experiments.
So here's what you do to find out what's wrong with electrodynamics. With Maxwell's theory. So it all starts with the double slit experiment. And you have this famous double slit, and some waves are coming from here. You have some wavelength lambda. Then in the back, I'm going to put a photographic plate.
And reason would tell you right from the start, right, even when you're going to talk about this, that, well, I should put a bunch of plates all the way around, right? I mean, I should just make a nice circle of plates equal distant, and then I can see this pattern as it actually happens at the same distance. That's the important thing. The same stretching, the same, I'll see it as it actually is, not as it's been distorted by casting on a flat surface. So they couldn't even, they can't even concede that, if we're going to talk about this pattern and what it looks like, you probably should look at it as it actually is happening, a fair view, not the unfair view of the house of bent mirrors. A straight plane to view it on is a bent mirror when you're talking about this kind of, when you're stretching something. So it's like having a lens that is broken and, it just distorts the image. This is, physicists should know you can't do it that way. That's the wrong way to do it.
A photographic plate, as you know, is made of this tiny little.
So if they did it with photographic plates going all the way around the surface, what they would find is, hey, there's no photons going this way, and there's no photons going this way, or this way, or this way, and there's only ones right here in the center. That's the only fringe pattern is created here, and it just fades out. Because it's not a wave function, okay? Waves say there should be photons. Just as many photons should be going this way and this way, being created along the sides of the experiment. The sides of the experiment should have just as much pattern as forward if it was a wave function. So they can't even get their own physics right. Their own description, their own love affair with waves, and they don't even know how waves work.
Pixels, which change color when light hits them, and then you see your picture. And that's the way to detect light. Perfectly good way to detect light.
Right, and another perfect way to do it would just run some photo detector back and forth, and it'll tell you where it's getting photons and where it's not. So there's lots of different ways you can do the detecting. Or you can just bounce it off a white screen and look at it.
So first thing we do is we block this hole, or this slit. This is slit 1 and slit 2.
But the photographic one, I'm just bringing it up for, this one would be much better, because they could do it with low intensity light, and they could see almost every photon, and they could really take a record over time and get, all that kind of stuff and be a very precise image. And they don't even go for that. Nobody's ever done it.
Block this, and we look at what happened to the photographic plate.
And when you think about billions of dollars,
what you will find is that
billions of dollars they spend on all this other crap, and they won't spend, because, for me or you, okay, photographic plates, all expensive, this and that, blah, blah, blah. But you're talking $10,000 to do the experiment well. And not a single physics lab has been willing to spend a little extra money to do the experiment really well.
The region in front of it got pretty dark, or let's say had an image, whereas if you go too far from the slit, you don't see anything. So that's called intensity.
So we know that the laser beam stays pretty intense, so I can cast it hundreds of yards, and my spot might get pretty big, but I still have a lot of photons. All right, so we don't have a real problem here, especially if we're talking about 10 meters away. So at 10 meters, you're going to look at your image, and the only part of the image that is going to be spreading is light that had to be diffracted. Any of the light that's going straight, it's going straight. It's still a laser beam. It's going straight.
And one is open. Then you close that guy, then you get
all right, so he did it again. All right, Feynman did it. They all do this. These two surfaces, these two openings are less than a millimeter apart. Less than. They're like a quarter of a millimeter apart. Tiny difference in their positions. And there's a laser beam going through them, and they're going to hit a target. It's almost as if the slits don't even exist in terms of how much they're going to cause the laser beam to diffract or go wider. So it's a complete canard that these two things would go this way and that way, that somehow I'm starting at the same millimeter of distance, and somehow I'm going to cast one of them is going to cast an image over there, and the other one's going to cast the image over there. No, it isn't. They're both going to cast it dead straight. So it's just complete lie. I say again, this really should be drawn as what will really happen, which I should be able to do right on top of that. Is that the two patterns will be right on top of each other, and there'll just be a millimeter of difference, just a little tiniest bit of difference. But that's how it's going to really happen. That's the truth versus their canard, their deception that somehow these two things are, that's what it does if you throw baseballs through or some other kind of bullshit. No, that's not what it does. It's not the truth.
Similar pattern, then you open both. Then I told you, you may expect that, but what you get instead, let's see, I got to pick my graph.
So of course he drew even that wrong, because clearly this is the only place where the two things he drew are overlapping. So this is the only place where the light will increase, is right here. So we should have this arc exactly the same, and then it peaks up here. Oh, yeah, peaks up here and then goes back down. That's how he should have drawn it, right? Because this is the only overlap here. This will be exactly the same with the other slit, with both slits open. This is going to be the same intensity, It only gets more bright here. It only heights here. So he didn't even draw that correctly.
Properly is something that looks like this.
So obviously it doesn't look like that. And so they don't even, playing this a game with the intensity. And again, not conceding that the intensity is key to wave theory. Because wave theory says it should be the same intensity all the way around. Every location should have the same intensity. Every single location, the whole 180 degrees should have the same intensity.
Now that
is Richard Feynman's drawing. It's just pathetic in terms of how much it steals from the actual pattern and what the actual pattern can look like. It's just terrible. Single slit, double slit, doesn't matter. They just do this. No double maxima. Nothing. And this is the foundation of quantum mechanics. Do you understand? This is their foundational experiment. This is what's defeating Newton and Galileo and Maxwell. This is our big experiment to prove that it's all wooey crap. And this is how badly they're going to describe this fundamental experiment. Why? Why is it this bad?
Is the phenomenon of interference, which we studied last time. So what's the part that's funny? What's the part that makes you wonder? Is if you go to some location like this.
So again, we're going to do the same argument about this idea that somehow there's an absolute proof that this ever does happen. So I'll just keep saying it, that the only way they can make it happen is synthetically. They have to cheat somewhere. They have to filter out some of the data. They have to change something because it actually doesn't happen. And they should be able to film it happening. And that is the key ingredient to filming it, is just leaving the aperture exactly the same size. When you change the slits, you just take the photograph with the aperture at exactly the same size. And that way you won't be able to cheat the intensity and force something to look darker than it actually is.
Go to a location like this. This used to be a bright location when one slit was open. It's also a bright location, reasonably bright, when the other slit was open.
So he says it's reasonably bright when obviously that was the declining line, so that's where they're not crossing over anymore. But the fact is that it's still exactly the same intensity, and all you've done is create more intensity on top of it, so it looks relatively dim compared to the bright spots that are much brighter. But that's all. It's just relatively dimmer.
But when both are open, it becomes dark.
So it doesn't become dark. It just looks relatively different. So that's it. All you've done is bleed it out of being bright by having something brighter next to it. That's it. Complete. That's the absolute truth. And again, the double slit done well proves it, because you can see the missing little bits, the little fringes that are missing. If you really look, you can see they're still there.
So you can ask, how can it be that I open two windows, room gets darker, why doesn't it happen there and why does it happen here? The answer is that you're sending light of definite wavelength, and the wave function psi, whatever measures the oscillation, maybe electric field, magnetic field, obeys the superposition principle. And when two slits are open, what you're supposed to add is the electric field.
So we're just going to pretend that the photons aren't real things and that somehow they actually can crash into each other and obliterate each other and make each other go away. And it doesn't happen. And again, the radar experiment and the radio experiment proves that it has nothing to do with wiping out energy. So I can put the same radio station, pumping the same exact frequency, and I put a receiver between those two transmitters, and I can create on, off, on, off, on, off, on, off. Demonstrating this doesn't have anything to do with somehow the light here interacts with the light here, and they somehow crash out in here somewhere and decide to make a photon. They don't crash. Light doesn't interact with light. Force doesn't interact with force. It has to interact with matter.
Not the intensity. The intensity is proportional to the square of the electric field. You don't add E squared, you add...
All right, so this is more of just they say so. So we'll jump ahead a little bit and get back to some real science, not this fake math crap. So he's just talking about little tiny bars here, so you understand that part. We already did that. All right, let's see where he's going here.
Able to turn down the brightness. Maybe you can, maybe you cannot. But you can imagine moving the source further and further back. Okay, you move it further and further back, we know the energy falls like 1 over r squared.
All right, we know it doesn't happen for a laser beam, so that's not true. So, what's the point, right? I mean, he's just saying something again. That only works for the spherical source of light. So the inverse square law doesn't work for laser beams. Laser beams don't get weaker and weaker because they're not separating in their distance this way and this way. They're not obeying the inverse square law. Oh, God. It's really bad. It only works for spherical sources. The inverse square law is a spherical law. Basically just saying that, yes, you're stretching something this way and you're stretching it this way. You can see how that makes a square. Laser beams aren't doing that.
So you can make it weak. So here's what we try to do. We put a new photographic film. We take the light source way back.
Okay, so this is what we try to do. They don't do it. So it's just, again, he's just describing an experiment they never do. All right, so this is sort of an interesting point. So I think I'll draw a little of this. So let's say you wanted to do this diminishing of light thing. Okay, you want to create one photon in an experiment. So you're going to have a light source. You're going to try to create this idea of just one photon at a time going through your experiment. It's really interesting because he's bringing up a point that I've never seen talked about or doing. But the idea that you could put a light, a candle or something, I don't know, 30 feet away, okay, from a little tiny aperture. All right, and then you're going to collect your photons on a screen, and all this is done in the dark. Now, to me, that's an honest experiment in the sense that your light source really does have to send one photon, okay, kind of an idea, and there's no pieces. You're not doing anything to break the photons, so you're not creating noise photons, at least not, you're not adding noise. So you have the least noise this way. But the way they do it, they don't do it by putting, the candle, a mile away and seeing how many, well, like I said, what's realistic? 50 feet you could do in a building somewhere. Have a little light bulb 50 feet away in complete darkness and see how many photons you can collect on a photographic paper, and just make your hole the size necessary to get a fringe pattern. But what they do instead is they put slides in here, dirt slides, so something to absorb the light, essentially. And so those slides are really just made of being smoky. Okay, so they're just, it's called smoked glass. So it's just that it's dirty. Okay, there's a bunch of places. So essentially it's a bunch of slit experiments. It's a bunch of surfaces. Okay, so there's a clear place, and then there's a dirty place, and a clear. So the light is going to get banging into a bunch of surfaces, and it's going to be fringing all over the place. So it's going to be creating a ton of little broken pieces of photon, frankly. And so it's going to be a completely different experiment if you do it with the light unbroken, okay, by a bunch of obstacles that you've put in the way of the light. And we know obstacles put in the way of the light will screw the light up. So obviously it'd be better to do the experiment without screwing it up. So I don't, this was the original experiment done by, it's rather a famous guy, the guy Newton hated, I believe. And they let the experiment go for 40 days or so. So what they did is put I guess it was a gas flame, and in a closed enclosure, with obscuring glass, and then a little hole, and see if it made the pattern. I think they actually used something to cast a shadow first, and then they used a double slit, I think. Unfortunately, this stuff isn't conserved in history. History doesn't conserve reality. So it's, there's a paper written about it, but it doesn't have, an abundance of detail. But anyway, so this is the pursuit to see exactly how this happens. But the argument I'll make is that obviously the math is telling you, screaming at you, that the outside surfaces are creating the small nodes in the double slit. There's no other rational way to understand it. The math is perfectly as vectors from these two faraway surfaces, and they're the ones creating it. So obviously there has to be a photon hitting this surface and a photon hitting this surface for there to be a photon created at the target. It needs both sources to send energy. So it's kind of telling you that you can think you only have one photon in your experiment, but what you have is a bunch of broken pieces of photons, and you're just going to say, in that field of broken pieces, I'm going to put two surfaces, and I'm going to see if I can remake a photon out of the pieces. And that's all you're really doing. Be my argument that that's all you're really doing. All right. So let's go back to his. But it is an interesting. I hadn't thought of, letting a light source travel a very long distance, a light source that isn't a laser, and therefore you're sure of getting photons that are moving pretty straight because they went the whole distance. Okay, so they're not coming in at an angle in any way, and then let them go into the surface. That would be a very good experiment. Very interesting. But that one hasn't been done.
Then we wait for
Gotta put it back on. And such.
something to happen. We come the next morning, we find there's a very faint pattern that's taken place overnight because the film got exposed all through the night. Now we can see a faint pattern. Then you go and turn it down even more. Then you come back the next day, you look at the film, you find no pattern, just 2 or 3 spots which have been exposed. So you look at the screen. So let me show you this.
So this, he's really just making the argument that it's corpuscular. So here he's shooting Newton down. And frankly, he's making a pretty good argument defending Newton.
View of the screen. Normally, you will have bright and dark patterns on the back wall if you turn on a powerful light. But I'm telling you, if you have a really weak source, you just find that got exposed, that got exposed, and that got exposed. That's it.
Yes, no waves present, no idea of a wave, no blurs and intensity and none of that. Yes. Point locations.
Only 3 points in the film are exposed. And that is very strange, because if light is a wave, no matter how weak it is, it should hit the entire screen. It cannot hit certain parts of it. Waves.
Right, but you should also know that your pattern shouldn't get weaker and weaker. So if it's a wave, so you already had evidence it wasn't a wave.
Don't hit certain parts of it. In fact, how can it hit just one? For example, if you make it weak enough, you can have a situation where in the whole day you just get one hit.
And what does one hit mean? It just means that the surface registered a photon. And I would argue that registering a photon isn't going to happen. One electron can't make a photon. One takes atoms, and it takes basically the same thing. The same way we detect photons is the same way they're created. We detect them by them creating electricity. All right. And that's essentially how they're created, radio waves. You're sending electricity through atoms. You're sending electron pressure through atoms. And in doing that, you're changing the position, the polarity of the atoms. And at a sequence, a speed of light sequence. And depending on the material you're changing will decide the distance between, how big the atoms are is going to decide what the period and frequency is going to be of the light.
So something is hitting the screen and it's not a wave.
Well, the period is the frequency. I meant the polarization and the period.
Because wave is spread out over its full transverse dimension, but this is hitting one point on the screen. So you make further observations and you find out that what happens here is that a certain amount of momentum and energy are delivered during that hit.
All right, it's not about how much momentum is delivered, it's about how quickly the momentum is delivered. So that's the key feature. That's why the high frequency light is able to do more dramatic things, is because it's delivered quickly.
If you could measure the recoil of that film, you will find it gets hit, and the momentum you get per hit looks like h bar times k. I'll tell you what it means.
Yeah, so we're back to the energy being controlled by the frequency, and it's really being controlled by the time you're applying the momentum. But it's not really more energy. It just is capable of breaking things. So ultraviolet light can break things that infrared can't.
This is
It's not that it has more energy. All right, let's see. I think a little bit in here, this gets boring math crap, and then he goes back to talking about some experiment, I think. So let's get through that. And yeah, we have X's and O's again, so that's good. Okay.
Then the atomic or molecular size, it looks like it's continuous. So that's not the bad news. The bad news really has to do with the fact that if you have these particles called photons, if it really were a particle, namely a standard garden variety particle, what should you find? If you emit a particle from here, and only one slit is open, it will take some path going through the slit and it will come there. So let us say on a given day, 10 photons will come here. Well, let's say 4 photons will come here with this one closed. Then let's close this one and open this one. In that case, maybe 3 photons will come here. Well, let's say again 4.
So again, we don't have any explanation for their diffraction. And the point is if they do diffract, okay, whether they're going to be photons or not is an open question. But we know if there's two places, if there's 2 open slits and they're less than a millimeter apart, we know that the patterns are going to be right on top of each other.
Now I'm claiming that when both are open, I get no photons.
So we're back to that argument where that doesn't happen. I'm claiming that doesn't happen, and you have no credible experimental evidence demonstrating that to happen.
How can it be that when you open a second hole, you get fewer particles coming there?
It can't be. So as soon as you demonstrate that's actually true, then you might have some part of an argument, but you're still going to fail because you haven't passed any of the other tests of actually describing the actual patterns that actually are produced.
Particles normally either take path number 1 or path number 2.
And that's exactly what the math says they do, in the sense that there's obviously a bunch of photons coming in. You've put 4 surfaces into the experiment. A certain percentage of the photons are going to hit the surfaces, and you know that's also true because the wider the slits are open, the more light goes straight through. The less the slits are open, the more the fringe pattern owns the territory, and there are no photons that get through without being damaged, without breaking. So therefore, there's no light in the center almost. It's so weak. So you can destroy all of the forward photons by just making the surfaces so close that no photon won't go near the surface. And you can guarantee that all of them will be fringe photons. They'll be diffracted. They'll be scattered. But you obviously still need the 2 sources. And in the 4 case, you need the 4 sources. And each one of the sources is a different photon that's been broken. Pieces from different photons, not pieces from the same photon.
Either through this slit or this slit. To all the guys going this way, they don't care if this slit is open or closed. They don't even know about the other slit. They do their thing, and guys going through this slit should do their thing. Therefore, you should get a number equal to the sum. But you don't.
All right, so there's just no evidence that you don't, okay? And so, this is just him says so, not evidence says so.
In other words, for particles which have definite trajectories, opening a second slit should not affect the number going through the first slit. Do you understand that? Particles are local. They're moving along, and they feel the local forces acting on them, and they bend or twist or turn. They don't really care what's happening far away, whether the second slit may be open or closed. Therefore,
right, so he's attempting to make an argument against particles by saying, how could particles disappear? And yes, the argument is, well, they don't, and you're claiming they do, but you don't have any evidence that they do. So show me the evidence.
or logically, the number coming here must be the sum of the number that would come with 1 open and 2 open.
And the argument
How can
is,
you cancel
with 2 open, you get many more opportunities because it's 2 extra sources. So you're going from 2 sources to 4 sources, and therefore you have a lot more opportunity to make other photons. And those other photons are going to be very bright because there's going to be a lot of extra photons in the experiment, twice as many. So you've brightened the whole experiment. And if you don't adjust your camera for that fact, that is, if you don't turn off the aperture, automatic aperture compensation, well, then you're not going to be able to see it as it actually happens, that you have twice as much light in the experiment.
Positive number of particles coming somewhere with more positive number of particles coming from somewhere else. How do you get a 0?
Well, you don't. So again, he just keeps saying it, and he doesn't show us an experiment, doesn't say, here's the proof. He doesn't show us the proof, just says it. So it is an extraordinary claim with not even ordinary evidence.
That is where the wave comes in. The wave has no trouble knowing how many slits are open because wave is not localized. Wave comes like this. It can hit both the slits and certainly cares about how many slits there are.
Right, and we know that that math won't work with the slits open. If I make 2 wave centers here and I do the math from the wave centers, I'm not going to get the right answer. The only way I'm going to get a right answer is with 4 waves created on each surface, 1 wave on each surface. So again, your assumption about how the water goes through the surfaces is part of the, you got it wrong. It don't work that way. The math proves that wrong, so I shouldn't have to make the argument because the math proves where the sources are, and the sources are the surfaces. That's the wave centers. The wave centers have to be the distances where the surfaces are.
Because there's only one, that wave will go, it'll have some amplitude here, which is kind of featureless. If that's open, it'll be featureless. If both are open, that'll be.
So 4 surfaces is not 2 waves. And even if I collapse these 2, okay, it's still not 2 waves, but it still is 2 sources. So there's going to be 2 waves here, but they're going to be from the same location, so essentially the same centers. That's the only way you can, again, you have to turn the four surface experiment, the two slit, into a single slit. And that's exactly the pattern you get, is the single slit pattern. So the point is proven.
Interference. So we need that wave to understand what the photon will do.
So he didn't draw the actual patterns. He doesn't show that there's a huge difference between the single slit and the double slit. The double slit clearly is two patterns superimposed on each other. So there's no acceptance of the actual physical experimental evidence. All right, I don't know if we need much more of this.
Because when you send millions of photons, and if you get the pattern like this, let's say you sent lots and lots of photons, and you got a pattern like this. Now I'm going to send million plus one photon. Where will it go? We do not know where it will go. We only know that if you repeat.
All right, so there's more nonsense about how we don't know. We know it goes through one or the other. So again, this is just all kind of bullshit. And it's just our limitations, our inability to see. We know that the laser beam has photons going in all kinds of different places inside the beam. And they're all heading somewhere. And it's just bullshit to say something else is happening.
The experiment.
We clearly can interrupt them with little particles of dust. You can interrupt the little wave, right? The ray. I mean, dust proves essentially that lasers are rays, right? Because you can hit an infinitesimally small little piece of smoke and the light will bounce off of it. So it's obviously not some spread out thing. It's something in a tiny, tiny, tiny location. And the whole giant photon hits that smoke particle and flies into your eye. So clearly, indicating that there's nothing waving. It's a ray of light.
A million times you get this pattern. But on the million plus one attempt, where it'll go, we don't know. We just know that the odds are high when the function is high.
All right, so he's just doing his math bullshit, so not interesting. And I think that's all we need here. I think this is the photoelectric effect, popping things out of the well. So, we've been there and done that. So I think we'll just call that enough of it. And I think that's lenses. Well, he's doing it again here with this drawing of the, back to creating this diffraction. So, and de Broglie is involved somehow. So he's saying this is the electron experiment. And clearly, putting electrons through a slit should to everyone be kind of, what are you talking about? How can you put electrons through a slit? They're charged. How could they not see atoms over here and atoms over there? Electrons see, matter. If there's a matter around, the electron's seeing it and it's going to react to it. All right, it's going to be bent by it. All right, enough said. So we'll call that a video and such. A bit long, but it's really important. And all these people pretending to be concerned for the integrity of science don't care that the physics they're shoving down people's throats is founded on such inaccurate statements about reality.